Okay, so I have a question from the Cal 1 class, and this is what it says. It says we want the graph of this function, okay? So f of negative 4 is equal to f of 1 is equal to 0, okay? So since we want a graph, I think we should start graphing this stuff, okay? So negative 4, 1, 2, 3, 4, there's negative 4, and f of negative 4 is going to cross the x-axis there, okay? And f of 1, so there's 1, right? And f is going to cross the axis there. So it's going to cross in two places. So, you know, might be some kind of a parabola or something that could cross in two places. Lots of stuff could cross in two places, though. Okay, so we have the first derivative of f at negative 1.5 is equal to 0, okay? Now, one of the definitions of the first derivative, okay, is that, you know, let's say we have a function, okay? There's some kind of a function, okay? And then, you know, at different points, okay, let's call this A, B, and C, okay? At these different points, you know, we can evaluate the function. Of course, it's a continuous function, right? And at any of these points, we can draw tangent lines, okay? So this would be a tangent line. This would be a tangent line, okay? Tangent line being a line that touches the function only at one point. And this would be the tangent line at C, right? Now, of course, you know, all these tangent lines have a linear equation that represents them, okay? Well, this M right here, okay, the slope of this tangent line is f prime evaluated at A, okay? And this one also, of course, is going to be y equals mx plus b, okay? And this slope right here, okay, of this line, at this point, is going to be f prime of b, okay? So then this slope of this line is going to be y equals mx plus b. So m is going to be f prime of c. And since it's a horizontal line, since it's horizontal, okay, the slope in this case is going to be 0. So this is why, you know, the first derivative of a function evaluated at a point is also called the slope of the tangent line. Slope of the tangent line to the graph at that point, all right? So we can use this information. So we know that at negative 1.5, okay, so this is negative 1, this is negative 2. So this right here is going to be negative 1.5, okay? So right here, we have a horizontal tangent line, okay? So there's a horizontal tangent line to the graph of f. Now, we don't know where it is, okay? We don't know, you know, is it up here, is it down here? We don't know where it is, but we know that it's horizontal, okay? Okay, so what else do we know? We know that for x's that are less than 1.5, okay? So in other words, in this area here, right? We're talking about x less than 1.5. So that's this area right here. This is x less than 1.5, right? And in this area, f prime of x is less than 0. So that means that the slope of the tangent line is negative. So there are negative lines that are slopes of tangent lines over here, okay? That means that the function is decreasing, okay? So now we have a better idea of what this thing looks like, okay? We know that it's decreasing here. This is the line x equals negative 1.5, okay? We know that the function is decreasing because the first derivative is negative. In other words, it has a negative tangent all over here. It crosses the x-axis at negative 4, okay? And then it's 0 when x is negative 1.5. We also know that f prime of x is larger than 0, so it's positive. So we have positive tangent lines for any x larger than, okay, so that tells us pretty much what we're talking about here. We're talking about some kind of a parabola with its vertex here on this line, okay? So this function is going to look something like this, okay? And it's going to meet these parameters. Now, since we know the zeros, right, we can say that x plus 4 times x minus 1, this could be f of x, okay? Now I say this could be, right? Because any constant out here could also be f of x, right? Because we don't know how pointy this thing is. We don't know where this point is, right? It doesn't tell us. If they told us the location of this point, then we could nail this down and get an actual unique function. Okay, so important to understanding, you know, the idea of the first derivative evaluated at a point gives you a slope, okay? And that slope is the slope of the tangent lines of the graph at that point. Important definition. Okay? If you have any further questions about this, send me an email.